Hello, let me introduce process for continuous integration and continuous deployment for the engineering. So we will extend the very popular method how the software is built in current days, continuous integration and continuous deployment from the software to the engineering, including SysML v2. We could do v1, but we will do v2 integrations to Jenkins for CI/CD pipeline. So this will be automation engine for this engineering pipeline. Then will be GitLab for the repository. Then will be Confluence for the wikis. And there will be cat and will be code for the design side, because from the SysML we will extract the changes and we push those changes based on the mechanical or functional type to the appropriate design, and then we'll generate the code and we'll use the updated CAD for 3D print to the actual product. And this product is the portable configurable stock market ticker, and will demonstrate a streamlined engineering process for innovative project development. This is completely reproducible CI/CD pipeline, which is actually the future of engineering. But we will present that in a week at INCOSE international workshops, but also in the month we will be able to package it and document it and give you to deploy in your organization. So now here what we can see, here is the Jenkins. This is the pipeline automation. As you can see here, we have tasks like validate the project. So SysML v2 has REST API on Teamwork Cloud. So we run validation, then we extract requirements and diff, verify requirements, running simulation, actually evaluation on SysML v2, then update the code, compile code, then put that code on the GitLab, and then do the mechanical design, then push the mechanical design to Git, extract the diagrams in SVG as you can see here, and then sync everything to Confluence. As you can see here, everything is in Confluence. So now this pipeline kicks in when we actually commit new changes to the server. It's very common to do that, and you can kick in the pipeline from any tool. So this is like integration automation engine. You kick in that from anything committed, it could be like design committed and so. But in our case, if you type major version update, requirements change. Actually, what changes we did, we can take a look here. We did what type of the functional requirements, like software requirements. We did that only those stock market tickers we want to see, and then we want the box corners of mechanical structural design will be rounded, and also box would be orange. Then we commit the changes. Major requirements updates. Elements of data, and then we tag it as the major. We could have different tag, and that's actually triggers the CI/CD pipeline. So if you go here, you will see soon in a second, pipeline kicks in, and those are like historical versions, and this is actually like newest commit with the major tag. Okay, so that committed, right? So now we can take a look that pipeline will kicks in. How that kicks in happens is that Teamwork Cloud has webhooks, and webhook is the thing what this pipeline is listening for. And once it finds that a major tag was used, it starts the execution. So project validation, so we can check first thing, like this is validation error, actually warning, which actually project got validated by SysML v2 validation, and this is the warning which was found. So we can see all the warnings. If there would be error, this would not continue. It would actually stop. So here we extract requirements diff. So we can take a look at log. You see like all the Excels and CSVs with requirements diff were generated. All that got pushed to GitLab, but also I can see them here. You see requirements diffs, right? Then I see requirements verification. I can take a look. I see those requirements verification. I can see the script. Yeah, here you go. I can see the script requirement verification. I see that, okay, it was evaluation of the model executed, and the back mass rollup, the back of the box got too heavy based on the recent changes, or maybe previous changes, or we don't know, but it's just too heavy, right? Still passed because overall mass is in margin, right? Okay, that's like requirements verification. Again, we use REST API for that. Then we have code update. Can check that code got compiled. New one requirement change, as you remember, right? And got updated and compiled. And then we have 3D cat update, and then we'll push everything to Git. And also we push everything to the Confluence. Confluence, we can see here all other projects. You see SysML v2 projects. That's other pipelines. Spacecraft rollup, Monte Carlo analysis project. The good thing is that those diagrams gets updated, but the text stays same. So this is the wiki which gets automatically updated, right? Then here we have GitLab, right? All those scripts, so SysML v2 projects you see here pushed, right? So SysML project, this textual specification, right? Exported as a SysML standard, and all the scripts, So this is the requirements extraction and delta. So I can take a look, for example, this is like just generated Excel, I can download here and see what are the differences. Okay, script tree, log, this is the code, updated original code, and then updated code, compiled, and then cat, you see the cat updated mechanical design. All of that, you see here, the cat is updating in progress, updating mechanical design, and then push to Git, extract diagrams. So we'll get the diagrams from the model. Again, using REST API of refresh 1. This will be released in June. So this is like early access to that. But in general, it will work. With even current release, you can get like almost like everything here working. And then sync diagrams to Confluence. Once we have exported them, we could use actually Magic Lab and show those everything, but we just want to export those diagrams and push to Confluence, and that will be end of the pipeline. So here we see code compiled, then we see 3D cat updated, so we can actually open the cat file last downloaded and see how that looks like in the viewer. Okay, let's open the viewer. Here's the cat. Here you go. So round corners, orange color, right? As requested. Okay, what's next? Push everything to Git. So we already take a look at that. Extract diagrams. So we can take a look at those diagrams. We can take a look here, You see like here we see the changes, orange, 3 millimeters. But also we can take a look at that in the Git, in the Confluence. And if we will refresh, This is the last commit. You see that those are the stocks. That's the last requirements diagram. The diagrams. Now let's go back. And we have synchronized to Confluence. So this is end of this pipeline. So this pipeline is actually see historical. We can take a look, at anything historical. You can see the same artifacts directly in the Jenkins. Also, we push to the GitLab, right? A very popular solution. But Jenkins, in our case, is actually doing, as we can see here, he's doing pipeline management, and GitLab is doing repository part, Then we push not only the requirements we push based on the type to the design, but also we trigger the design update, and then we can deploy it to the actual product. So this is the streamlined engineering process for innovative project development, leveraging CI/CD, and it is expanding CI/CD to actually engineering in the proper way. We can actually add anything more, but it's already quite a lot. And it is quite universal, so it works with other projects also. You can see here car braking analysis, SysML V2 project, and so on. Just the pipeline depends what you want to do for the engineering side, but for system side is the same. Validation, requirements extraction, pushing to Confluence, generating SysML code file, and then running a simulation or evaluation, requirement simulation. Okay, thank you.